Hello, and welcome back to the History of Knowledge. Today, we dive deep into the life and work of one of the greatest minds humanity has ever seen, Isaac Newton, the genius behind gravity, motion, and the very laws that govern our universe. From the iconic falling apple to the groundbreaking formulation of the laws of motion, Newton's discoveries reshaped the way we understand the cosmos and laid the foundations of modern science. Isaac Newton was born in 1643 in Woolsthorpe, England, a time of turbulence, both politically and scientifically. His early life was marked by challenges. He was born prematurely, and his father passed away before his birth. Despite these hardships, Newton's curiosity and relentless pursuit of knowledge began to emerge at an early age. He attended Trinity College, Cambridge, where he immersed himself in mathematics, physics, and natural philosophy, the precursor to modern science. It was during the plague years, when Cambridge was closed, that Newton returned to Woolsthorpe and began a period of extraordinary productivity. In isolation, he formulated the fundamental principles that would forever change science. One of his most famous observations, the falling apple, symbolized more than a mere fruit descending from a tree. It represented a question that led to the formulation of the law of universal gravitation. Newton asked a question that no one had dared to ask. Why do objects fall toward the earth, and how does this relate to the movement of celestial bodies like the moon and planets? Newton's law of universal gravitation states that every mass attracts every other mass in the universe, and the force of this attraction is proportional to the product of the masses, and inversely proportional to the square of the distance between them. This was revolutionary. For the first time, humanity had a mathematical explanation for both terrestrial and cosmic motion. His calculations accurately predicted planetary orbits, fundamentally linking the heavens and the earth under a single principle. Beyond gravity, Newton's contributions to physics are immense. His three laws of motion, the foundation of classical mechanics, describe how objects move and interact with forces. The first law, often called the law of inertia, asserts that an object remains at rest or in uniform motion unless acted upon by a force. The second law quantifies how forces change motion, expressed famously as F equals ma. The third law, a staple of every physics textbook, declares that for every action, there is an equal and opposite reaction. These principles are not only crucial to understanding planetary motion, but also underpin modern engineering, aeronautics, and even everyday actions such as driving a car or throwing a ball. But Newton's genius did not stop at physics. He revolutionized mathematics by developing calculus independently, a tool that allows scientists to describe change and motion mathematically. Calculus enabled the precise modeling of dynamic systems, from planetary motion to the growth of populations, and remains indispensable to scientific and technological progress today. His work in optics was equally groundbreaking. Newton demonstrated that white light is composed of a spectrum of colors, famously using a prism to separate light into its constituent hues. This challenged centuries of belief in the simplicity of light, and paved the way for modern optics and color theory. Isaac Newton also made significant contributions to astronomy. Using his laws, he explained why planets orbit the sun in elliptical paths, confirming Kepler's earlier observations. His work allowed astronomers to predict the motions of celestial bodies with unparalleled accuracy. Indeed, Newton's insights laid the foundation for future breakthroughs in space exploration, satellite technology, and even the search for exoplanets. Despite his towering intellect, Newton was also a complex and sometimes reclusive individual. He engaged in intense rivalries with fellow scientists, including Robert Hooke and Gottfried Leibniz, particularly over the invention of calculus. Newton's later years saw him occupy a prominent role as the warden and later master of the Royal Mint, where he applied his analytical skills to reform England's currency and combat counterfeiting, demonstrating that his genius extended beyond theoretical science into practical governance. The legacy of Newton's work is monumental. Modern physics, engineering, space exploration, and even our understanding of the universe itself are built on the principles he discovered. The phrase "standing on the shoulders of giants," which Newton himself popularized, is a testament to the cumulative power of human knowledge, and Newton himself became a giant whose work continues to illuminate our understanding of the natural world. Today, as we gaze at the stars, calculate the trajectory of spacecraft, or even rely on GPS systems, we are engaging daily with the principles Newton uncovered. His work is a reminder of the power of curiosity, observation, and relentless inquiry. Newton teaches us that one question, asked with rigor and imagination, can change the course of human knowledge forever. His journey from a curious child in rural England to one of the most influential scientists in history exemplifies how intellect, perseverance, and creativity can transform the world. In conclusion, Isaac Newton was more than a scientist. He was a visionary whose work transcended the boundaries of his time. Gravity and motion were not merely theoretical concepts for him. They were gateways to understanding the universe itself. The genius of Newton continues to inspire scientists, thinkers, and curious minds around the globe. From the apple that fell in his garden to the celestial mechanics that govern our solar system, Newton's legacy is immortal. Thank you for joining us on this journey through the life and genius of Isaac Newton. Stay curious, keep questioning, and remember, the pursuit of knowledge is the greatest adventure of all. This has been another illuminating episode on the history of knowledge.